Alright, just because we're getting close to test time, so your test is going to be next week. I can't quite say how long it's going to be quite yet because, truth be told, I was busy writing the pre-calc test this past week, and so now that that is done, now I can focus in on writing this test. So I will get that done probably today or tomorrow, and then I'll probably get it done today, and then I can let you know by tomorrow how many questions it's going to be, and that like. But these are from earlier in the chapter, and so these two warm-up problems are great. So why don't you try these two warm-ups right now? All right. So this first one would be I have 3x y to the fourth on top from the first fraction. I have 9x cubed y squared from the bottom of that first fraction. Okay. This would go into there and into there, and that would give me 9x to the fourth on top. This would also go into there, and that would give me y to the sixth on the bottom. Okay, so then these 9's can cancel each other out. This x cubed can cancel out 3 of those, leaving me with just x. This y to the fourth can cancel out 4 of those, leaving me with just y squared. So what I'm left with is, on top I've got 3x squared, here, here, and here. And on the bottom, I've got y to the fourth power. Yes? What do you mean? Yep. Yep. Oh, this x right here?
Yeah.
Oh, sorry. I just kind of wrote it a little high. Yep. Here, we'll get that. Because I canceled out 3 of the x's from the bottom. Yeah? Alright. Second one. Leave x plus 3. That's 6x squared minus 3x plus 4x is plus x. And minus 2. And then multiply by x into all of those. And that's going to give me 6x cubed plus x squared minus 2x. And then multiply by 3. And all of those, that would be 18x squared plus 3x minus 6. Add them together, and I get 6x cubed plus 19x squared plus x minus 6. Agree? questions on that? Again, you could have done that in any order, but you got to take only 2 at a time. Okay, so we could have taken the x plus 3 and the 2x minus 1, or the x plus 3 and the 3x plus 2, multiplied them all together. But in the end, we would all end up in that same number. Okay? All right, so wrapping everything up today with the last day of notes, of actual notes for Unit 3. And then we'll review tomorrow, and we will review again on Monday, and then we'll have the test open starting on Tuesday for a week. Yeah? So, I want you to do it all. So, I want you to find me the list of possible zeros. I want you to find me the factored form. I want you to find the actual zeros, and I want you to write out the end behavior form. Okay? So I want you to do it all on this one. Okay? Go for it. All right. So my list of possible zeros, well, that's going to be 1 and 2. Right? Factors of 2 divided by factors of 1 is only going to be 1 and 2. Okay? Love it. Did you find one? Uh-oh.
I know one of them is
1, positive 1?
maybe x minus 1.
Okay, so let's just make sure that 1 works. So we got negative 1, 0, 3, and negative 2. Negative 1, negative 1, negative 1, negative 1, 2, 2, 0. Yep, okay, so that one works out. So that's going to give me, you said what, x minus 1?
Yeah. And then after that, it was x minus 1.
Negative x squared minus x plus 2. Okay, I like it. Would you be offended if I drew out that negative sign? Like this. Like that. Does that work? I like factoring with positives on my square terms. Okay? Is that factorable? I think so, right? Plus 2 and minus 1? So then my factored form would be forgot the negative. Would be negative, and then x minus 1, and then x plus 2, and then another x minus 1, or we could have written it as that. So combine those two to the same term. Okay. So then I need to solve x minus 1 equals 0. That's going to give me x equals 1. X plus 2 equals 0. So that's going to give me x equals negative 2. So all my zeros are 1 and negative 2. 1 just happens to be a double root. Okay. And then, if I did a quick sketch of the graph, we didn't have to though on this particular one, but it's going to help us. But it's going to help us for end behavior. We've got a double zero at positive 1 and a single zero at negative 2. We have an odd coefficient or an odd degree with a negative coefficient. So that's going to come down through here, come up and kiss, and go back down like that. So my end behavior coming off of that would be as x goes to positive infinity, f of x is going to negative infinity. Because as we're going to the right, we're going down. And as x goes to negative infinity, f of x is going to positive infinity. Because as we're going left, we're going up. Okay? Question? Same thing. Try that one. So my list of possible zeros is 1, 2, and 4. Yeah. We find one that works. Negative 2 works. One, 0, 3, 0, 4. Yeah. One, 2, 4, 1, 2, 4, 0. Okay. We get another one that works. Positive 2. Yep. And I'll show you why I knew both of those would work here momentarily. 1, 2, 0, 0, 1, 2, 0. Okay. Way back up here, just so that you guys know, we could have factored this as x squared minus 4 and x squared plus 1. Because it's a trinomial, could have been factored like that. Okay? But that's fine. I'd rather go through these steps. Okay? So this one would give me x plus 2 as a factor. This one would give me x minus 2 as a factor. So then my factored form, because I know I can't factor this, so my factored form then would be f of x equals x plus 2, x minus 2 and x squared plus 1. Like underneath?
Not really. It just comes out of your list. You know. But yeah, there's not really a every time this one's gonna work. Yeah. Unless you graph it. I mean, if you graph it, then you can see. You know. Yeah. So all of our zeros, then.
So we would go x plus 2 equals 0. So x is going to be negative 2. X minus 2 equals 0. X is going to be positive 2. X squared plus 1 equals 0. So that's not factorable.
So I could use the quadratic formula on it, okay? Or
I could subtract 1 and go x squared equals negative 1. Then square root both sides and go x here equals plus or minus
the square root of negative 1,
that's I. So all of my zeros are plus and minus 2, plus and minus. Sketch. So just a quick sketch of this graph. So we know that we crossed over at negative 2, positive 2. We had a positive lead coefficient on our even degreed term. So it's going to come, whoa, hey now, what happened there? So it's going to come from up high, come down, that. So as x approaches positive infinity, f of x approaches positive infinity, and as x approaches negative infinity, f of x approaches positive.
Yep. Good. That's all I got for you today. I give you too much work time, so or too much example time. Got enough work.